So, topic today is we're talking about function notation. Okay, function notation. So, example 1, it's not in function notation. So, let's see if we can use these input values. We can take a look at the graph and we can decide whether it is a function. It probably is. So if these are my input values, those are like my x's, right? So let me do a little chart with this. So there's my x values, right? And let's make our y values, all right? So if I plug in -2, I plug it in for x, right? So now I'm only going to do a couple of these because the rest we can do in our head. So if I go y equals, I plug in my -2, I'll go -2 plus 3. Well, that's going to be a +1, right? Plug in a -1, I'll go y equals, so I plug -1. -1 goes into x, right? So I'll go -1 plus 3, and that's a +2, right? And so then I'll plug in 0, but I can just do that in my head. I don't really have to use a chart. I can just be smart. 0 plus 3 is 3, right? 1 plus 3 is 4. Looks like I got a pattern going on, huh? 2 plus 3 is 5. And then 3 plus 3 is 6. Well, these are technically points. These are points, right? So if I look at my points, I'm going to have a point at really -2, 1. I have a point at -1, 2. I'll have a point at 0, 3. I'll have a point at 1, 4. I'll have a point at 2, 5. And I'll have a point at 3, 6. So if they are points, I'm going to graph them. See what it looks like, okay? So let's see if I can put these points then on my graph and see what I get. So let's see, I'm going to have a point at -2, 1, right? -1, 2, 0, 3, 1, 4, 2, 5, and 3, 6. Well, you know, and if I kept going and going and going, basically we get a line, right? So real quickly, easy question. Is this a function? Function, yes or no? Yes. Yeah, because it's going to pass that vertical line, and every x value has exactly 1. So we say yes, it's a function, okay? So if it is a function, I'm just going to rewrite it, okay? Instead of y, let's write as f of x. So take the exact same, and instead of writing y, just write f of x. Because it is a function, is equal to x plus 3. There it is. We rewrote it as a function. Just instead of writing y, we wrote f of x. That's all I did. I said, wait a minute, it is a function. Yeah, so I don't need to say y anymore. Let's just say f of x. That's as easy as it gets, okay? Now, example 2, it is a function. I don't know what it looks like, but it doesn't matter. I know it's a function because it says f of x. Yes, this is a function. That's a function because it says f of x. So we're going to plug in 0. So f of 0 is to plug it in. So to get f of 0, I'm going to go, all right, f of 0 is equal to, like, plug 0 in. 0 squared plus 6 times 0 minus 10, right? So f of 0 is equal to -10. Because I know 0 squared is 0. 6 times 0 is 0. So minus 10 is just -10, okay? F of 2. So to get f of 2, we're going to plug 2 in. So 2 goes in for every x. 2 goes in for every x. So I put 2 right there for x squared. So I'm going to go 2 squared plus 6 times 2 minus 10. Okay? It's kind of squeezed in there, but we'll make it work. So let's simplify. F of 2 then is equal to 4 plus 12 minus 10, right? I went 2 squared is 4. 6 times 2 is 12 minus 10. That's 16 minus 10, so f of 2 is going to be 6. You okay with that? f of negative 2, same thing, just plug it in. F of negative 2 is going to be, well, plug it in for every x. That's all we do. So we'll go negative 2 squared plus a 6 times a negative 2 minus 10, okay? Just plug it in. Now I know when I plug in negative 2, a negative times negative is positive. So this becomes a, so f of negative 2 is equal to, let's see, that's a positive 4 minus 12 minus 10. So I'm going to have a negative 22 and a 4 makes a negative 18. So f of negative 2 is equal to negative 18. Okay. Now before I move on, what I want to do is this. What I need is, this is a point. Okay, you got to remember, these are actually points. 0, negative 10. These are points. They don't look like points in this form, but I plugged in 0 and I got negative 10. So these really are points. This is a point. It doesn't look like a point, but if I plug in 2 and I get 6, it's a point at 2, 6. Okay, this is a point. Same thing, this is a point on the graph at negative 2, negative 18. So it really is. It doesn't look like a point right here, but it really is a point. Negative 2, negative 18. Okay? Now the domain and the range. So let's back up a couple of days. What I told you is the domain were all the x values. So the domain are the x's, right? And the range is the y's. So in this example, our domain is 0, 2, and negative 2, okay? So our domain in this example is the points 0, 2, and negative 2. And our range is the y's. So our y's are the negative 10, the 6, and the negative 18. So it's a set negative 10, 6, and negative 18. If we were to graph this, and we didn't, but if we were to graph this, we'd see a parabola. And then we'd talk about the domain and range being something totally different. And I'm just going to show you. You don't need to know it yet. But if I were to graph this parabola, it would look something like this. And so then we'd talk about the domain and range being totally different because all of these points are on it, right? And we'd have a totally different, we'd have a lot more in our domain because every single one of these points would be on it. But for right now, domain, my x value is x, 0, 2, and negative 2. And my range, which is the y values, is negative 10, 6, and negative 18. Okay. Now, example 3, is it a function? Is this a function? Is this graph a function? It is. I mean, it doesn't have an equation. It's just like a dot, dot, dot thing. It's like a bunch of lines, but it is a function because it would pass the vertical line test, right? So from the graph, find f of negative 3. Now that's an x value, isn't it? That's an x value. So let's go find 1, 2. There's negative 3, right? Its answer would be its corresponding y value. So f of negative 3 is 1. So f of negative 3 is 1. I went back, x value of negative 3, 1, 2, 3. And the corresponding height of the y value is 1. It's that easy. Okay? So f of 0. What's f of 0? 2 is totally right, you guys. 2. You're here at 0. What's the height? The y value is 2. Isn't this easy? What's f of 1?
2.
2. You guys agree? Here's my 1 on my x. And what's the height? It's 2. Nice job, Dylan. F of 2. What's f of 2?
1.
1. You go to 2 on the x. Got an x value of 2, and the height is 1, or its corresponding y is 1. Okay, that's easy. Can you guys do that? Of course you can. All right, you ready to turn the page? Okay, turn the page. All right. All right. Next example. Oh, I want to back up. You guys want to back it up? Let's back up. Let's talk about domain and range of this. Let's back up. Example 3. Let's talk about the domain. The domain is all the x values. So the domain is really all of these x values, okay? All of them and everything in between. So the domain goes from negative 4 2, 1, 2, 3, 4, 5, 6. The domain is all the x values from negative 4 to 6. So I'm going to do that in interval notation. I'm going to go from negative 4 to 6. I'm saying from negative 4 to 6, and everything in between, that interval is my domain. It's all those x values. The range is all my y values, or reach for your range. So what's the lowest y value? 0. And what's the tallest y value? 3. So the y values exist between 0 and 3. Again, I used interval notation. Isn't that easy? The domain is what are all the x values, and the range is what are all the y values in our graph. Okay. Now, I'm sorry, let's turn the page again. Okay, there we go. Okay, heart rate. So what happens is as you get older, unfortunately I know this, you slow down. It's a bummer. So if this is a diagram of women's ages and their maximum heart rate. So what I want to do is a graph. So age has to go here because that's the control variable. The older you are, the more it affects your heart rate, right? So I'm thinking, okay, I got to go all the way to 40, so maybe I'd go, let's go maybe 10, 20, 30, 40. That'd work if I go 10, 20, 30, and then 40. How's that? Now I got to go 209, 202, 195, 188, and 181. So I'm doing a little scrunchy. You guys ever see this little scrunchy thing here? You guys ever see the little scrunchy thing? You ever draw a little scrunchy? You guys ever see this little scrunchy thing? I'm compressing the graph so that I can start at 180. So 180 is right there, okay? And everything in here has been compressed. Does that make sense? So I go 180, then I go maybe 190 here. And I go 200 here. I go 210 here. Okay, age, and this is heart rate. How am I doing? So, I mean, I didn't obviously want to put all the numbers in between 0 and 180, so I do a little scrunchy. So I squished it, I compressed my graph. So let's do a dot to dot. At 0, age 0, which is right there on the x-axis, I'm going to go to 209. So I'll put a point right there at 209, okay? Age 10, I'll go to 202, so I'll put a point right about there. Age 20, I'll go to 195, so I'll put a point right about there. Age 30, I'll go 188, which is about right about there. Then age 40, I'll go 181, which is about there, okay? Looks like a nice straight line, which it should be, okay? Okay, how's that? All right, what's the independent variable? What's the independent variable?
That would be right.
It's age, because age is always the one. The independent variable is always this variable, okay? It's the age, right? So the independent will always be the horizontal. What's the dependent variable then?
Right.
Heart rate, right? Okay, heart rate. Heart rate. Okay, good. Now, to find an equation for this function, I'm going to help you with that because you guys really haven't done this for a while, but it seems like you're dropping.
-7.
Is it 7? So it's -7, totally right, -7 for every 10. You okay with that? So you're dropping 7 for every 10 years. So you go down 7 for every 10, right? And then what's your starting amount?
209.
So let's go like this. Let's see if we remember to do this. It's some algebra 1. So if we go y equals -7/10 x plus 209. Okay, that's an equation. But we want to put it in function notation, okay? So let's go ahead and figure out what's going on. So x and y are not very good variables. This thing doesn't have to do with x or y. It has to do with age and heart rate, right? So let's change the x to a for age, and let's change the y to h for heart rate. So I'm going to go h of a equals -7/10 A plus 209. Okay, now I'm going to start there, okay? So what it is, two things. One, x's and y's don't make any sense in this problem. This has nothing to do with x's and y's. X's, y, this has to do with age and heart rate. So I changed my variables into age and heart rate, right? Then I wanted it as a function notation, so it has to be something like this, where d of t, h of t, f of c. So I wrote it as heart rate with respect to age, okay? All right, and that is it. Not a lot of homework. You can get it done in class. We call it classwork, okay?